Welcome all. Today we will see the presentation of the different types of lamps, which is unit number 2 of subject Illumination Engineering of 5th semester of the Electrical Engineering of diploma students. The course code for the subject is 22530. So at the end of this presentation, the student will be able to select the relevant lamps for various application. This is the course outcome for the for this unit. So first of all, we will see the classification of the electric lamps. The electric lamps are majorly classified into four groups. One is discharge lamps, fluorescent lamps, halogen lamps, and incandescent lamps. Then again, discharge lamps are subdivided into three groups. One is sodium lamp, then sodium lamp, which is having the low pressure sodium vapor lamp and high pressure sodium vapor lamp. Then second one is mercury lamps, which is again having the high pressure mercury vapor lamp and low pressure mercury vapor lamp. And last one is neon 2. Similarly, the incandescent lamp will be again subdivided into two parts or two category. One is gas filled lamps and another one is vacuum lamps. So in this presentation we will see the or talk about the incandescent lamp. So we will see first of all the introduction, then construction of incandescent lamp, then working of incandescent lamp, its advantages, its disadvantages, and finally we will see the application of incandescent lamp. So first of all, introduction. An incandescent light bulb, incandescent lamp or incandescent light globe is an electric light which produces light with a wire filament heated to high temperature by an electric current passing through it until it glows up. Then the hot filament is protected from oxidation with a glass or quartz bulb that is filled with inert gas. The most bulbs are used in a socket which provides mechanical support and electrical connection. The construction of incandescent lamp is shown in this figure, which is having the different parts. First we will see the glass bulb, which is used for the mechanical protection for the bulb and for the atmosphere. Then second one is gas filling, which is, as I told you, the incandescent lamp is classified into two types. One is gas filled and another one is vacuum filled. If it is vacuum filled, the vacuum will be there, and if it is gas filled, then there are two types of inert gases which we will use in this type of bulb. One is argon with small percentage of the nitrogen. Then again, krypton is the base gas for this purpose, but it is so expensive that it is used only in special applications. Then tungsten filament, through which the electric current is passes. Then we will see the lead wires through which the external electric supply given to the tungsten filament. Then again the another one is duplicate wire, exhaust tube, steam, fuse and cap, which is inserted into the socket or the lamp holder. So this is the two types of the lamp which I already told you. One is vacuum filled and another one is gas filled. So in vacuum filled there is no conduction or convection loss but more rapid evaporation. Means when the electric current passes through the tungsten filament, there is loss of heat, and due to heat is generated, and due to generation of heat the particles of the tungsten is evaporated. So in vacuum there is more rapid evaporation of the tungsten filament. Vice versa in gas filled incandescent lamp, where the inert gases like argon is used with some particle of nitrogen. In this case the evaporation of the filament is comparatively less as compared to the vacuum filled lamp. Therefore, the efficiency of this lamp, gas filled lamp, is more as compared to the vacuum filled incandescent lamp. So, the filament which is used in the lamp must have the some property. So these are the property which the filament should have. First one is it should have the high melting point, means it should not be melted at low temperature. It should be withstand the high temperature. As temperature is more, the heat will be more and we will get the more light. Second one is it should have the high resistivity, so that it will be heats up immediately. Then it should have the low temperature coefficient. Then it should have low vapor pressure, means the pressure of the vapor should be low in the bulb or the lamp. Then it should be mechanical strong and ductile. The material used for the filament is carbon, osmium, tantalum and tungsten. But generally the tungsten is used for the filament because it has a very good characteristics, like it has the high melting point, high resistivity. That's why generally the tungsten filament is used for the filament material. The gas used inside the lamp, as I told you, it is nitrogen or argon. The lifespan of this lamp is 1000 hours, working hours, and the lamp efficiency is 10 to 30 lumen per watt. The efficiency of the lamp is measured in lumen per watt, means how much lumen it will give per watt, that is the efficiency of the lamp. So incandescent lamp gives the efficiency in between 10 to 30 lumen. It is low as compared to the other types of lamp that we will see in next presentation. So the working principle of this lamp is based on the principle that when an electric current is passed through a fine metallic wire, heat is produced and the temperature of the wire increases. At low temperature, the wire radiates heat energy. As the temperature of the wire increases due to heating, it radiates heat as well as the light energy. The higher the temperature of the wire, the higher is the amount of light energy radiated. A black body, when heated to 6000 around 6200 degrees centigrade, emits the maximum energy in the visible spectrum range. So as we know, we have the visible light view in the wavelength in the range of 4000 degree Armstrong to 7500 degree Armstrong, depending upon the color of the light. So near to the 7000 we will get the reddish color, and near to the 4000 degree Armstrong we will get the violet color, depending upon the wavelength of the that light energy. So this is the working principle of the incandescent lamp. Incandescent lamp generates light through heat, means 95% heat and 5% of the light. When electric current, as I told you, the electric current is passed through the tungsten filament, it will generate the heat, and at the temperature it will starts glowing and gives us the yellow or light color. So this is a simple working principle of the incandescent lamp. So what are the advantages of the incandescent lamp? First, it will operate on unity power factor, means as there is no any coil or inductive material or induction is introduced in this type of lamp, it will operate at unity power factor. Then operates directly on the normal voltage, means it does not require any type of the regulator low to step up or step down the voltage. So it generally operates at the normal voltage. Next, available in various shapes and size, very cheap in cost, handy and easily fixed up, and produces yellow light, which is near to the sunlight. So what are the disadvantages of this type of lamp? The life is less as compared to other lamp. The power consumption is more. The filament may break due to vibration and shock. As the filament is very delicate, so it can break due to shocks or any vibration. The frequent switching produces thermal stress on the filament. As we can on and off regularly the lamp, the thermal stress on the filament will increase and it may break. So these are the disadvantages of this type of lamp. Then what are the applications of this type of lamp? They require no external regulating equipment, have low manufacturing cost, and work equally on either alternating current or direct current. Means it can operate on AC supply as well as on DC supply. So as a result, incandescent lamp is widely used in household and commercial lighting, for portable lighting such as table lamps, car headlamps, flashlight, and for decorative and advertising lighting. So this is all about the incandescent lamp, and at the end uh, there is one video on the incandescent lamp which will again clear your doubts about the history of the incandescent lamp, its working and its operation.
Contrary to popular belief, the original light bulb was not invented by Thomas Edison, but Sir Humphrey Davy in 1809. Creating the first electricity-powered light, the invention was greatly refined 60 years later by Edison, designing a powerful bulb that could burn for up to 40 hours. This was the first incandescent light bulb. To understand it, we first have to recognize light at an atomic level. At its most basic form, light is seen as a series of particles called photons. They are created as excess energy packets when an atom's electrons suddenly gain and lose energy. When an atom is energized, its electrons shift further away from its core. When the energy stops, the electron returns to its natural orbit, releasing built-up energy as a photon. By repeatedly energizing atoms, it's possible to generate a steady stream of light energy. In a light bulb, the energy source needed to energize the atoms is provided via electricity traveling through its base. Electricity simply being the movement of free electrons. The key component that made Edison's design so groundbreaking was the filament at its center. Being the most important part of a light bulb, it's the size of the filament that determines the intensity of the light emitted. In an everyday bulb, the filament is about 50 centimeters long, but is coiled down to a smaller size, then coiled again, leaving a 2 to 3 centimeter piece in its place. Tungsten is usually chosen for its extremely high melting point. Electrons burst through the filament, but because it's so tightly coiled, they'll frequently fly off and bump into each other, causing the filament to light up and become extremely hot. All this takes place inside an airtight bulb. If the reaction were to take place in open air, the heat generated would be enough to ignite the surrounding oxygen, destroying the filament. However, in a vacuum, when the filament is heated, the vibrating tungsten atoms occasionally break off. If enough do this, the filament splits and the light bulb is broken. To counter this, the empty bulb is packed full of an inert gas such as argon or krypton. With the gas, any atoms that break off bounce off the gas atoms and rejoin the filament, effectively quadrupling the bulb's life. Although incandescent light bulbs are a staple of modern technology, they've been proven to be very inefficient. An everyday light bulb produces about 20% visible light, with 5% released as light outside our visible spectrum, such as ultraviolet and infrared. The rest is produced as heat, leaving the bulb red hot. To counteract this, the fluorescent light was invented. Using an entirely different process, it's 5 times as efficient at producing light. This will be discussed in a later episode. There are 3 main components to an incandescent lamp: the free-moving electrons traveling through its base, the airtight gas bulb filled with inert gas, and the tightly woven tungsten wire at its center. All working together releases billions of photons, observed as visible light.